0.20 volts per count. And what will happen in reality, though, is if we get a 0, this means 0 volts. And if we got a 15, this would mean 3.3 volts. So the best approximation for this could be, you could look at it and say it's our full scale voltage, 3.3 volts, divided by 15 counts, times the count that we found, which was 11. And this is, and actually, if you divide by 15, so 15 is probably a better number. It's actually 0.22. So 2.22 volts is a better per count representation, because we really don't get that 0 at the count. Okay, so the way I like to think of this is in terms of percentages. And so if we had, well, I don't know, I'd like to explain this very slowly and go into a lot of detail that if you've had any amount of math, you might think, wow, he's going into a lot of detail that's ridiculous. But I want to make sure everybody follows this, right? So if you have a fraction, and in this equation here, we have our full scale voltage, our voltage full scale, times our, we're going to call this our ADC count, and then it's all going to be divided by the full scale count. For this class, it's always 3.3, but it may be different if you have a different analog to digital converter. And in this example, we're using 15 for the full scale count. For the chip, it's actually 1023. But if we just look at these two, right? So this one's always 3.3, and for this example, this one's going to be 15, and this is the one that's changing. But the ADC count is only ever going to be between 0 and 15. By definition of what we're doing here. Though I haven't given you the definition. So ADC count, it's changing, but it's going to be between 0 and 15. And so if we just look at this part of the equation here, you could have the lowest value would be 0 over 15, and the highest value would be 15 over 15. So 0 divided by 15 is 0. And 15 divided by 15 is 1. And all the values in between, 1 through 14, are going to be some fractional value between 0 and 1. So if you think of fractions as percentages, 1 is 100%. And 0 is 0%. So if I have 0 here, I have 0% of my 3.3 volt voltage. And if I have 15 there, I have 100% of my 3.3 volt voltage. So this portion of the equation basically just translates into a percentage of this full scale value. And then when you multiply that percentage times the full scale value, you get your voltage out. Or your voltage in, actually. Voltage in. So if we were around halfway, around 7 or 8, we would have about 1.65 volts, which would be about 50%. 8 divided by 15 would be 53%. So approximately half. So approximately half of it. How many bits does it take to represent 16 unique values?